Not until that moment when man-carrying rockets probe the transonic range will any research be so packed with thrills for the pilot as with the current tests of human transonic flight in the Air Force's rocket-propelled XS-1 airplane. Because of the limited supply of nitrogen under high pressure stored in the airplane, the aircraft's fuel system must be checked for operation and possible leaks prior to flight. For making the necessary pre-flight check on the engine, the airplane is loaded with both propellants and nitrogen. Liquid oxygen from the storage tank is transferred by means of an insulated hose and a firmly seated connection to the tank in the aircraft. The oxygen filler valve is turned on and the tank vented to allow the liquid oxygen to boil off, thereby cooling the tank during the filling operation. A tank trailer is brought up containing a 65-35 mixture of alcohol and water by volume, respectively. As this fuel is pumped into the aircraft, it must be carefully screened and filtered to remove the minutest particles of foreign matter. With the propellant tanks loaded with 311 gallons of liquid oxygen and 293 gallons of alcohol and water fuel, the aircraft is then loaded with high-pressured nitrogen gas. This serves to pressurize the fuel and operate the landing gear, flaps, and adjustable stabilizer. At a spot remote from the filling site, for safety reasons during engine ground check, the aircraft is anchored and each cylinder is fired to check the operation of the igniter, propellant valves, and the complete motor unit. Between tests, a fine spray of water purges each cylinder to prevent fires. During these test runs, the number of cylinders may be increased to include all four. Shock waves appearing in the flame produce a bead-like appearance. After pressure checks on the nitrogen system have been made and ground test runs of the engine completed, the now defueled aircraft is towed to a loading pit near the fueling site and ready for a pre-flight inspection by one of the Air Force pilots selected for flying this experimental supersonic airplane through regions heretofore unexplored. Initiated in March 1945, with its first glide flight in January 46 and first powered flight in December 46, this Air Force aircraft built by Bell and equipped with NACA instrumentation has a wingspan of 28 feet and length of 31 feet. The engine tubes and control surfaces are closely inspected and checked by the pilot himself. Here, structural design criteria had been arbitrary and based principally upon ignorance. Since it had not been possible to predict with any degree of certainty the loading distributions and possible buffeting in transonic flight, the airplane was designed to withstand 18G ultimate. Without fuel, it weighs less than 5,000 pounds and carries 8,000 pounds of fuel. Since the wing thickness is only 8% of its chord, the thickness of its machine-tapered covering is quite unusual. Of conventional thickness at the tip, its thickness increases to 1/2 inch at the inboard end. To complete this pre-flight inspection, the pilot must check the controls in the cockpit for operation and movement. Here, in spite of the restricted loading pit, all 2.5 tons of it. Once aligned with the loading pit ramp, the XS-1 is carefully lowered by cable to its position for suspension from an especially modified B-29. On this carrier aircraft or mothership, the bomb bay doors have been removed, along with the tunnel connecting the forward and rear pressurized compartments. Removal of the tunnel was necessary to provide headroom for the tail of the XS-1 when hoisted into its carried and launching position. Suspended by one standard Air Force D-4 bomb shackle, this transonic aircraft is to be borne aloft and released, thus eliminating the hazards of a conventional takeoff. Considering that almost 2/3 of this rocket-powered aircraft's gross weight is fuel, the dangers of a takeoff from the ground are obvious. Close tolerances between pit dimensions and landing gear tread on the B-29 require expert handling by the ground crew, particularly the operator of the tug. Close tolerances, too, between the mothership and the XS-1 are closely watched, for even the slightest damage to the nose or tail section of such a high-speed aircraft result in the direst consequences. Fabric straps connected by cable to the standard bomb hoist are used fore and aft to raise the airplane into position for connection with the bomb shackle. Once connected, braces will prevent swaying of the suspended aircraft. In order to fit the XS-1 as closely as possible into the bomb bay of the mothership, it had been necessary to cut away a section forward of the bomb bay, as well as portions of the fuselage section of the rear bomb bay. With the loading operation completed, the mothership is towed to the nearby fueling station for refueling the suspended XS-1. Here, the same procedure of fueling with liquid oxygen, the mixture of alcohol and water, and the pressurizing of the nitrogen spheres is repeated. During refueling, the exposed sections of the oxygen line and the skin adjacent to the oxygen tank forward of the wing become coated with a layer of frost. This fueling operation normally takes about 1 hour, during which time every precaution and control is utilized to ensure a safe transfer of propellants and nitrogen gas. Upon completion of fueling, the B-29 is backed away. With ground clearance of the XS-1 barely a matter of inches, the mothership is now ready for takeoff. For locating the XS-1 in flight, a modified SCR-584 radar set is used. This installation permits accurate tracking, plotting, and airspeed altitude calibration of the airplane. An FP-80 aircraft assigned to this project is used for a chase ship and for photographing the XS-1 in flight. To enable the photopilot to keep the XS-1 in photographic range, a bomb sight was converted for use as a movie camera finder. A last-minute check between one of the engineers in charge and the B-29 pilot is made prior to boarding the airplane for takeoff. One of the greatest problems during the development of this project was the unpreventable loss of nitrogen pressure during the period of climb to launching altitude. Therefore, as rapid a climb as possible must be made to that altitude. Aside from the recognized dangers during fueling, getting this fully fueled experimental aircraft off the ground was, during the earlier takeoffs, considered a hazard. However, after 12 months of successful takeoffs, this procedure has been proven comparatively safe. During the same period, aborted flights were few and far between. These were caused by either some minor malfunction of equipment or a sudden and unfavorable change in weather. Here, with clouds beginning to obscure visible contact with the base, fuel in the XS-1 is jettisoned. Preparations are made by the crew of the B-29 for landing with the XS-1 still attached. During the earlier flight stages of this project, such a procedure was not desirable due to possible damage or loss of the XS-1 in an attached landing. But it has since been demonstrated that landings can be made with a reasonable margin of safety. Again refueled and checked out for another flight, the B-29 climbs as quickly as possible to the predetermined altitude. This may range from 15 to 30,000 feet. During this climb, contact is checked with the trailing photographic P-80 and the ground-based radar and radio installations. Inside the B-29, the crew and pilots check their equipment for flight at altitude and the checklist of coordinated procedure. For flights below 50,000 feet, standard Air Force personal equipment is used by the pilot of the XS-1. For the pilot's protection in entering the cockpit of the suspended aircraft, a small elevator lowers him to the level of the cockpit opening. Upon entering the cockpit, the pilot fastens his shoulder straps and safety belt and connects his oxygen mask and intercom. By that time, The cockpit door is lowered, positioned, and secured from the inside. This procedure invariably takes place at an altitude of 3,000 to 5,000, and the checking of the procedure list continues with the XS-1 pilot sealed inside his aircraft. Here the elevator can be seen in its lowered position opposite the cockpit door. Now, with contact and coordination established with ground radar and radio, and the P-80 photographic airplane, the moment draws near for launching. 5 seconds. 4, 3, 2, drop. Number 1 cylinder is turned on, and the initial charge of alcohol appears as a puff of white vapor. Then, as oxygen is injected, the igniter fires the cylinder with flame and resultant thrust produced. With 1 cylinder firing, the photographic P-80 jockeys into position for a tail-on angle. With 4 cylinders producing maximum thrust, an almost vertical climb is possible. At higher subsonic speeds and approximately 8 miles away, the ground-based radar operators have to be on their toes while tracking. With the contractual flight test program with Bell completed in June 1947 and Air Force acceptance of the XS-1, 1 airplane was assigned to NACA for detailed stability, control, and loads investigation. The earliest of these flights were accomplished in October 47. With NACA cooperation, the Air Force initiated an accelerated Transsonic program on another XS-1, also in June 47. These flights with Air Force pilots were started 2 months later. These programs are being continued with the now favorable prospects of attaining speeds exceeding Mach number 1 and altitudes heretofore unexplored by any man-carrying aircraft.
Although the XS-1 was designed for ground takeoff, all flights performed during the accelerated Transsonic program were initiated at high altitude. This was done in order to utilize the limited fuel supply to best advantage. However, at the close of the program, a conventional takeoff was proposed for the purpose of evaluating XS-1 performance in this regard. After filling propellant tanks and performing a weight and balance check at the loading pit, the airplane was towed to position, accompanied by a fleet of firefighting and rescue equipment. It was considered desirable to perform takeoff as quickly as possible after filling to avoid the effects of liquid oxygen evaporation. It was also necessary to warm up the NACA telemetering equipment and the radar beacon while towing the XS-1 into position. To avoid excessive drain on the airplane's batteries during this period, the warm-up power was supplied by external batteries carried on the wing. Batteries were removed just before takeoff. The airplane was located to take maximum advantage of the expansive Muroc Lake area in the event of aborted takeoff or forced landing early in the flight. Then the pilot entered the cockpit and fastened his parachute and seat belt. The only concession to the occasion from the standpoint of special flying apparel was the use of a crash helmet. The airtight door was positioned by the crew chief and locked by the pilot after the XS-1 had been completely prepared for takeoff. Cylinders number 2 and 4 were started simultaneously, followed immediately by cylinders number 1 and 3. In less than 20 seconds and a run of 2,300 feet, the XS-1 left the ground, the first takeoff in the United States of an airplane propelled solely by its own internal rocket power plant. When viewed from the takeoff point, the tremendous dust cloud in the wake of the XS-1 gives evidence of the mile-per-second velocity of the rocket motor exhaust, and again the acceleration imposed by the 6,000-pound thrust is apparent. To ensure flying speed after takeoff, the raising of wheels and flaps was delayed, but even during retraction, the angle of climb had to be increased to keep the airplane from exceeding desired climbing speed. When retraction was complete, the angle of climb increased steadily, almost to the vertical. The XS-1 glided to a skillfully executed landing after turning off the motor and jettisoning unused propellants at 23,000 feet. In less than 10 minutes after initiation of takeoff, the flight was completed and without incident.